Hey guys! All right, now we're going to today we're going to talk about the discriminant. Oh, this looks really scary, discriminant. Oh boy, it's really not that bad. Okay, well, we've talked about a few different ways to solve a quadratic equation. We've talked about graphing a quadratic equation, where you actually graph the equation to see what the solutions are, what the zeros are. Okay? Well, can it be used? Rarely can you use graphing. Okay, rarely. Honestly, this is very useless. Okay? It's hard to do if you do this by hand. If you use your calculator, it's kind of like you're cheating. And it's just not cool because it has to be on perfect lattice points, like where the points cross, in order for you to actually have any zeros that are worth finding by graphing. Okay? Well, the second one that we talked about was solving by factoring. Well, this can be used sometimes. All right, and it's only good when the equation is factorable. Only when factorable. All right, and if it's not factorable, then you can't factor it. Okay? Well, we also did some completing the square. Well, can it be used? It can be used all the time. Okay? Or always. I'll just put always, make it smaller. The problem is, it's kind of cumbersome. And by cumbersome, I mean it's hard and it can be a little messy and you might mess up. Okay? So, completing the square is not always a good idea. In fact, it's rarely a good idea. That's why we came up with the quadratic formula. You can always use the quadratic formula, and it's easy to use. You just plug in the values. The problem is it takes a long time sometimes. And, you know, it's just hard to write it all out. So if I had a choice, I would factor if I could. But if I couldn't factor it, I would use the quadratic formula. The discriminant, which is b squared minus 4ac, doesn't that sound slightly familiar? Can tell us how many real roots are in an equation. Well, you might be asking, what is this discriminant good for? Well, the discriminant is actually, if you notice this, if you remember, b squared minus 4ac, it's the stuff underneath the square root in the quadratic formula. Okay, well, we can use this cool information and the properties of square roots to be able to tell us which method to use to solve the quadratic. And so we can call this our little angel that will sit on our shoulder to tell us which method we should use. It's rather neat. So here's a little table to help you know which type of, how to solve and what kind of solutions you have. Well, if the value of the discriminant is negative, an example of a quadratic whose discriminant would be negative is x squared plus 3x plus 2. All right? No, plus 4. I'm going to make it plus 4. There we go. X squared plus 3x plus 4. And I'll show you. We've got b squared is 3, so that's 3 squared minus 4 times 1 times 4. Well, that equals 9 minus 16, which is negative 7. So this is clearly a negative discriminant. Okay? There are 0 real roots. No real roots. It doesn't hit the x-axis at all. Okay? It'll look like this or like like that. It'll be a frowning face or a happy face, but it won't ever cross the x-axis. The type of solutions, these are unreal, or these are not real solutions. Okay, so there's really not one for you to find right now. When you go to Algebra 2, you'll learn about how to solve these types of equations and find the imaginary solutions that exist. But for now, since we're not talking about the complex number line, we're only talking about real numbers, there's no real solutions here. Now, if the value of the discriminant is 0, for example, if I have, let me get a different color. Let's see. It's still, here we go. X squared plus 10x plus 25 equals 0. Well, let's see. B squared, that's 10 squared minus 4 times 1 times 25. That's 100 minus 100, which is 0. Well, the number of real roots when you have a discriminant of 0 is there's one real root. And the type of solutions that you get are real and rational. Okay? You only get one of them. And the way you would solve this is you can solve by factoring special patterns. Okay? You can solve by factoring special patterns. It's going to be a perfect square trinomial. This is one way you can tell if it's a perfect square trinomial. It's kind of neat. B squared minus 4ac, if it's 0, then you've got a perfect square trinomial. If you have a positive square, if it's positive square of an integer, for example, if I have x squared minus 3x plus 2 equals 0. Well, b squared, that's negative 3 squared, plus, b squared minus 4 times 1 times 2. Well, that would be positive 9 minus 4 times 2 is 8. That's 1. So this is a perfect square. 1 is a perfect square. There are two real roots, and the type of real roots, they're real and rational. Okay? And how you would solve these is you would solve by factoring. Okay? So this is a factorable equation here. Any of them that have a square as your answer for the discriminant. So for example, if you get 9, 4, 1, 4, 9, 16, 25, 36, 49, etc. Any of those perfect squares, if you get those for your determinant, you can factor the equation. All right, and the last one is if it's positive and not a square. For example, let's get x squared plus 5x plus 6. No, plus 3. There we go. Equals 0. All right, so in this situation, I would have b squared, which is 25, minus 4 times 1 times 3. So that's 25 minus 12, which is 13. 13 is not a perfect square, but it is positive, so I have two roots, and the type of solutions are real and irrational, meaning there's a square root in your answer. Okay, and you have to solve by the quadratic formula. Okay, or completing the square, but most of us would rather use the quadratic formula. Okay, so using this table, we can state the value of a discriminant and then determine the number of real roots for each equation. So here we go. It's b squared minus 4ac. So b squared is negative 2 squared minus 4 times a times c. Well, that's 4 minus 4 times 4 minus times 14. Well, clearly this is negative. And if it's negative, I don't really need to find how big it is. Okay. I will let you, on your tests or on your homework, if it's negative, just tell me it's negative, and tell me that the solutions are not real, and that is all you need to tell me. Okay? All right, next one. All right, here we go. First, I need to get it into the equation form. X squared plus 24x plus 144 equals 0. All right, b squared is 24 quantity squared minus 4 times a times c. All right, 24 squared is a really big number, but I'm going to square it. That's 16. 4 times 2 is 8. 8, 9, 96. Plus 0, 2 times 4 is 8. 4, so that's 576 minus All right, 4 times 4 is 16. 16, 17, and that's 576. So this is 576 minus 576, which is 0. So this is, there are, oh, this is 0 solutions. There's one real rational solutional. Solutional. One real rational solution. And I would factor by special patterns for that one. Here, I'm going to go ahead and subtract 12. So 3x squared plus 10x minus 12 equals 0. And b squared is 100 minus 4 times 3 times negative 12. And that is 4 times 3 is 12, so 12 times 12 is 144. So that's plus 144. 100 plus 144 is what is 244, which is not a perfect square. So this is two real irrational solutions. Okay? Since 244 is not a perfect square. So it's not factorable. Okay, next we're going to find the discriminant and then use it to predict the number and type of solutions for each equation. And then we're going to decide whether we can factor it or whether we should use the quadratic formula. So here we go. B squared is negative 1 squared minus 4 times 10 times negative 2. Well, that's 1 plus 4 times 2 is 8, 80, so that's 81. That's a perfect square. So there are two real rational solutions, and I'm going to factor it. All right. Okay, let's try B. B says 3x squared minus x minus 7 equals 0. B squared is negative 1 squared minus 4 times 3 times negative 7. Well, that's 1. 3 times 7 is 21 times 4 is, lost my train of thought. Okay, 3 times 7 is 21 times 4 is 84. So that gives us 85, which is not a perfect square, so this is not going to be factorable, so it's two real irrational solutions, and I'm going to use the quadratic formula. Okay? Now this one I'm going to go ahead and do 16x squared minus 40x plus 25 equals 0. So b squared is negative 40 quantity squared minus 4 times 16 times 25. Well, 40 squared, negative 40 squared is 1600. 4 times 25 is 100 times 16 is 1600. And that's going to be 0. So there's one real rational solution, and I'm going to factor by special patterns. And that's where we got it, right there. Okay? So now go to your warm-up and complete problems 1 through 3. All right, the next thing we're going to do is we're going to find a k so that the equation will have exactly one rational solution. Well, in order to have one rational solution, my discriminant needs to equal 0. So I'm going to set b squared minus 4ac equal to 0, and I'm going to see what that would make k. So k right here, a is 1, b is negative k, and c is 64. So we have b squared, which is k squared, minus 4 times 1 times 64 equals 0. Well, 4 times 64, 4 times 4 is 16, carry the 1, 256. So k squared equals 256. So k squared equals 256 is my, is after I subtract 256 from, or add 256 to both sides. Take the square root, k equals plus or minus, the square root of 256 is 16. So k could equal positive 16 or negative 16. I have two different solutions. Okay? So now go to your warm-up and complete problem number 4. Alright, so now what I'm going to do is I'm going to use the discriminant to actually determine what I'm going to do and follow through. So here we go. B squared is 2 squared minus 4 times, I'm going to put parentheses around that, 4 times AC, which is negative 1. Alright, so that's 4 minus 4 times negative 1 is 4 times 3 is plus 12, and that's 16. So since this is a perfect square, I'm going to factor it. It's factorable. So 3 times 1 is negative 3, 1 and 3, bigger one's positive, smaller one's negative. So this gives me 3x squared minus x plus 3x minus 1. It was factorable by AC method since a is bigger than 1. Factor out an x to the first two, and I have 3x minus 1. Factor out a 1, and I have 3x minus 1. And I'm left with, I need to put it equal to 0. That's 3x minus 1 times x plus 1 equals 0. So set each factor equal to 0. 3x minus 1 equals 0, and x plus 1 equals 0. So this one's the easier one. I'm going to subtract 1 from both sides, and I get x equals negative 1. Over here, I add 1 to both sides, and I get 3x equals 1. Divide both sides by 3, and I get x equals 1/3. There are my solutions. Alright, now we're going to solve the quadratic equation here. So 3x squared minus 8x plus 2 equals 0. Let's do the discriminant. B squared, which is negative 8 squared, minus 4 times a times c. Well, that's 64 minus 4 times 6 is 24. So that equals 40, which is not a perfect square. So this is going to have to, we're going to have to use the quadratic formula for this. So x equals negative b plus minus square root of quantity b squared minus 4ac all divided by 2 times a. Alright, so that equals 8 plus or minus the square root of 64 minus 24 over 6. Notice that I could actually just use my 40 that I've already got here. 8 plus or minus the square root of 40 over 6. Now 40, it has factors of 4 and 10, and 4 is a perfect square, so 40, the square root of 40, equals 2 square root of 10. So x equals 8 plus or minus 2 square roots of 10 over 6. And on the top I can factor out a 2 because all of these 2, 8, and 6 all have a factor of 2. So that's 2 times 4 plus or minus the square root of 10 over 2 times 3. The 2's cancel out, and that gives me 4 plus or minus the square root of 10 over 3. And that's what x equals. Ta-da! And that just helped me know that it wasn't factorable to waste my time. So now go to your warm-up and complete problem number 5. Well, what do you do next? Well, first go to Modo and answer these questions. What can you use the discriminant for? And how can you know that an equation has no real roots without graphing it? If you have a question, please ask me, and then bring your notes and cool down warm-up with you to class. Alright, I will see you guys later. Bye.